Hello, finance friends. Welcome to lecture 2. In this lecture, we're going to introduce and then learn in detail and then practice one of the most important concepts in all of finance. It's called the time value of money. If you can master the material in today's lecture, you're going to be set down the line to do lots of other really important work. Time value of money comes into everything from investing to retirement planning to figuring out mortgages and car loans and everything in between. So it's a really critical idea, and we're going to learn about it right now. So we're going to break this down today. I'm going to start off with some basic principles, some definitions, and then from there, we're going to narrow it down and talk about 4 specific types of calculations and how you do them. Throughout the process, one of the things I want you to keep in mind is not just the work, the formulas and everything else, but actually the applications of it. So we're going to try to also focus on that. When we start off with time value of money, there's lots of ways to open it, but I kind of want to start from a very broad bird's eye view and basically share with you 5 key ideas that we learn from a discussion of time value of money. So like what are some of the big ideas? What are the big kind of key principles that will stay with us throughout our discussion in personal finance? Well, number 1, a dollar that you have today will always be worth more than a dollar that you're going to receive in the future. This is a very important concept, okay? A dollar that you have today will always be worth more than a dollar that you expect to get in the future. The flip side of that is any dollar that you expect, any money that you expect to receive in the future will be worth less than money in hand today, okay? Second big idea is that money moves through time. There's a lot of ways that you can define finance, but one of the simplest ways is simply that finance is the movement of money through time. Money moves, it flows through time. In fact, I'm fond of saying that life, when it comes to your personal finance, is basically a series of cash flows. Think about it. When you put money into a savings account, you're putting it aside right now. That money is going to grow with interest through time and be available for you sometime later. Imagine a typical person who is doing retirement planning. You can imagine that your life, broadly speaking, is 2 windows of time. A working phase, which we might call the accumulation phase, where you're saving toward retirement, and then the retirement phase or the drawdown phase where you're living off of those savings. Well, think about this. When you are saving money and investing it while you're working, you're putting aside money every paycheck, every month, let's say. That money is moving through time and growing. And then when you retire and you start your retirement phase, you're going to be pulling money out of that account every month or so to live on. You're going to be drawing it down. Once again, the money is moving through time, okay? When you think about it, saving, investing, how about borrowing? We have here borrowing. Well, think about when you borrow. You come to me for a loan, I give you $5,000 right now, and you're going to pay me back a certain amount of money every month until it's paid off. I gave you a big chunk up front. You're going to pay that back across time, okay? So at its core, finance is the movement of money through time. The interest rate, one of the big variables that we're going to learn today, the interest rate describes the movement of money through time. So if you accept this idea that money moves through time, you can think of the interest rate kind of like the speed at which that money moves. And then the concluding ones, The power of time and time value of money is such an important, powerful concept because what we're going to learn, money is moving through time and the interest rate is the speed. Even small changes in either the interest rate or the timeline can have a significant impact on how your money grows. So, for example, if you can start investing even a couple years before you had planned to and extend the time that that money's growing, it's going to have a profound impact. Or even a small change in the interest rate will have a big impact. When you put all these together, the big takeaway from today is really that when it comes to you understanding personal finance, and especially when it comes to one of those buckets that we discussed in a previous lecture, that idea of accumulating wealth, time is going to be your best friend. It's a force that will be on your side if you understand its power, okay? Now, the flip side of that is, unfortunately, for people who don't understand the time value of money and they play the game the wrong way, time is not their best friend, it's their worst enemy. Because the same forces that work in your favor when you understand time work against you if you don't. Okay, so let's keep those key ideas in mind. There are a couple of principles, 4 basic principles that I'm going to lay out for you. Principle number 1 is that money, we said that money moves through time. Money can move in 2 directions. We call those 2 directions compounding or discounting. Now, to understand these 2 ideas, we have to introduce 2 terms. The first term is present value. Present value, or PV, this refers to what a particular sum of money is worth today. Now, this can very easily, if you have $1,000 in your pocket and you're sitting on it right now, then your present value is $1,000. At the same time, you can look at it differently. Suppose that you were entitled to collect $1,000 5 years from now. Suppose that I promised to pay you, said, hey, if you do well with this lecture series, 5 years from now, I'm going to give you $1,000. Well, that's $1,000 that you're going to collect in 5 years. Does that money have a value today? It certainly does. That's the present value. You know it's going to be worth less than $1,000, by the way, because dollar today is worth more than $1 in the future and the other way around. So that's the present value. The other one is FV, the future value. Now, to go back to my previous little example, if I promise to give you $5,000 sometime in the future, that's the future value of it. There's another way to look at it. Suppose that you set aside in a bank today $1,000 and it's growing at interest. How much will that money be worth in 5 years? So these 2 ideas of what money is worth today at present and what money will be worth at some point in the future, they're the flip side of the same coin. With that understanding in mind, here's how we think about this. Compounding is the process of moving from today to the future. Compounding, hence the term compound interest, refers to moving money, the movement of money from the present to the future. On the other hand, discounting is coming the other way. With discounting, we're actually going the other way. Discounting, and you may have heard the term discount rate, for example. Discounting is the movement of money from the future back to today. Okay, money can move in 2 directions, forward and backward, from the present to the future, from the future back to the present. Compounding and discounting are simply the very specific terms that we use. Speaking of compounding, it's probably a good time right now to introduce an important idea of interest. And let's start off with the idea of simple interest. Simple interest is the interest that most people think of when they think about, making money on a bank deposit. And simple interest has a very simple formula. I equals P times R times T. I is the interest, P is the principal, the amount that you start with. R is the rate, the interest rate that you're earning, that the money is growing at, and T is the number, the time period. Okay, so a very simple formula for simple interest, I equals PRT. So with that said, let's jump into a little sample question. Suppose that on January 1st of 2024, you put $1,000 into the bank account, and that money is going to grow at 20% interest. So we have a question here. In year one, in the time period between 1/1 and 12/31, how much money will you earn? In other words, how much will you have on 12/31? And we can do this with this formula. We can just do it right here. We'll say in year one, your interest will be equal to P times R times T. It's going to be the $1,000 that you deposited multiplied by the 20% interest rate, which we'll do as a decimal 0.20. We're looking at it for 1 year. So our T, our time period is 1, and this will be $200. Now notice that you started with 1,000 and you earn 200 in interest. So at the end of year one, you're actually going to have the $1,000, that's the principal that you started with, plus the $200, that's the interest that you earned. So you're going to have $1,200. Pretty easy. Now let's suppose that you decide to leave that money, which is now $1,200, in that account for another year. So you're going to leave it in the account. We'll do this in red for contrast for year two. And year two will span 1/1/25 to 12/31/25. At the end of year two, on December 31st of 2025, how much money will you have? Well, the year two interest is still going to be I equals P, equals PRT. So the interest will be I, which in this case is $1,200, times the same interest rate, 20%, times 1 year, that's going to be $240. This means that at the end of year two, what you're going to have in hand will actually be the $1,200 that you started with, that's your principal, plus the $240 that you earned in interest. So you're going to have $1,440. This is how we think about compound interest. Let's look at one more thing. Let's look at this a little bit differently. So you're going to have $1,440, but let's go back to year two. Get this cleaned up a little bit for you. We see that in year two, you're going to make $240 in interest. Of that $240, one part of it, $200, represents the interest that you earned on your original principal. So this is the interest on your original $1,000. But you're stuck with $40 that you have to account for. Well, that $40 represents the interest on your previous interest. Remember, in the first year, you made $200 of interest. Well, when you left that money in the bank, you earned interest on that interest. 20%, which is your interest rate, multiplied by the $200, that's the 40. And that, my friends, is what compound interest is. Compound interest is interest on interest. And this idea of compounding is a powerful force. In fact, for most of you, when you become wealthy, it's really not going to be based on the principal that you initially invest. It's going to be the compounding factor, the growth of money as you earn interest on interest. At a certain point, if you were to run this example for year 3, year 4, year 5, etc., you would find that every year you're making more and more money on previous interest. It happens to be the case that more often than not, for most investors, you earn more interest in growth on your previous interest in growth than on your original amount put in. Okay, we call this the miracle of compound growth. So that's what compounding is. One big takeaway that you need to drill into yourselves as you think about your investing and your financial future, you always want to maximize the power of compounding. You always want to maximize the power of compounding so you can get the most money from your money. Okay, with that said, let's go back to our principles now. So the second basic principle is that there are two types of time value calculations. We have what are called lump sums. This is where we're talking about one-time payments. By the way, in time value, whenever we talk about the word payment, it's a little bit different than would be used in everyday usage. A payment means basically either money contributed into or pulled out of an account over time. Okay. So with the lump sum, you're putting in one bit of money, one chunk of money, and then you're walking away. You put it in one time and then you're done. That's a lump sum. The other type is what we call an annuity. With an annuity, and annuity is one of those words that has different uses in finance, but in the context of time value, when you're talking about an annuity, you're talking about a series of recurring payments. So I'll give you an example. If you decide to invest $1,000 today, you put the money in the account and then you walk away, that is a lump sum. If you decide to invest $50 a month every month indefinitely, that series of ongoing recurring payments, that's an annuity. Okay, so those are our two types of calculations, lump sums and annuities. Now, when we're doing time value calculations, there's 4 or 5 components that make up every calculation. Okay, there's 4, sometimes 5 components that make up every single TVM calculation. So at the end of the day, while time value stuff seems very complicated, it's really pretty straightforward. All you want to do is ask yourself, what are my 5 variables? Let's identify it and let's solve. Okay, so what are the variables? What are the components? Well, number 1, you're going to have, as we discussed, your present value. Number 2, as we discussed, you're going to have your future value. Oops, that got messy. There we go. Number 3, you're going to have N. N refers to your number of periods that we're talking about. In other words, N is your time. Number 4, you're going to have I. Oops, we lost our thing there. Let's see if we can get it back. Let's see if we get this back. Sorry about that. There it is. Okay. I is our interest rate, which is going to be measured in a percentage. And then our 5th component is what we call PMT. This is the payment. Just so you know, these 4, present value, future value, N and I, we always have those four. The fifth variable, the PMT, the payment, this is only the case when you have an annuity calculation. Let's get this cleaner, sorry. Calculation. So when you're doing a lump sum, we're going to have 1, 2, 3, and 4. When we're doing an annuity, we're going to have all 5, okay? The great thing about this is all time value problem solving is just a search for the missing variable. That's all it is. It's just a search for the missing variable. I'm going to give you, or the problem will always give you, all but one of the variables. And your task is to simply solve for the missing variable. So when you think of it that way, you know, the jargon can confuse people, but you don't need to be confused. Okay, it's like a scavenger hunt. You're just looking for a missing variable. Take what you've been given, figure out what variables you have, figure out the missing one, and go and get it, and you're set. Okay, so those are your components. The fourth principle of time value is that there are always going to be several methods. I want this in blue, sorry. There are always going to be several methods to solve these problems. Okay, the first method is longhand. Basically, a formula. There are formulas for all the calculations. Now, some people love longhand. They like to write things out, and that's how their brain works. Some people think it's cumbersome. It's up to you. I will say that the formulas are generally pretty easy when we're talking about lump sums. They get a little bit hairy when we're talking about annuities, but that's one option, longhand. You can also use what's known as a factor table. This, which is on the website, is a factor table. If you notice on this, there are actually 4 tables. Let's identify them briefly. Notice that the first one is the future value of a $1 lump sum. The second table is a future value of an annuity. The third table, A3, the present value of a lump sum. And the fourth table, the present value of the annuity. That should make sense. If we only have present values and future values, and we only have lump sum or annuity calculations, then there's really only 4 kinds of broad calculations, and they're here. So you see that this table, this is called a factor table or a time value table. It's a shorthand way to solve these problems. So what you're going to first do is identify which is the proper table to use. Are we doing the future value of a lump sum? Or are we doing the future value of an annuity? Or are we doing the present value of a lump sum? Or are we doing the present value of an annuity? So the first thing you want to do is get the right table. Got to have that. Notice once you have the right table, and we'll just use this top one, that going across the top, you have the interest rates. And going down the side, you have the periods. So going across, this is your I, and going up and down, that's your N. So all you're going to do for a factor table is simply find the appropriate cell, the appropriate square that corresponds to a given I and N. You just put your finger here and here, you connect them, and that number tells a big story. We'll search this out in a bit. You have your factor tables. The third way that you can do it is with the financial calculator. Now, there's a lot of financial calculators, and there's some classics in business school and in finance that people use all the time. If you have one, great, but you don't need one. In fact, online now has a bunch of great ones. I tend to be partial to this one. If you go to calculator.net, actually, if you just go to do a search, just do a web search and search for financial calculator, Usually one of the top hits that you see is calculator.net. It's a free site. It's a really clean interface. I use it all the time, and that's what we'll probably refer to in future lectures. If you notice, there's a lot of stuff going on, and I can't annotate on this. So right up here at the top, you'll see that you have 5 tabs: FV, PMT, IY means interest per year, N, and PV. Remember I said earlier that you're always going to have all but one of the variables given to you, and you're on a scavenger hunt for the missing variable. Well, all you have to do is click whichever one you're looking for. So if you're looking for the future value of something, you click FV. Notice that when you click FV, N, I, PV, and PMT are going to be filled in. Because again, I'm going to always give you, the problem will give you all but one of the variables. All you do is plug in the variables, you press calculate, you solve your problem. These are really convenient, really handy. It's free and easy to use. Okay, that's our third one. And our fourth one, which we will not do in the course of these lectures, but which are still popular, you can also do these calculations through Excel. There's a handful of macros in Excel that actually build in this. Okay, we're not going to do that just because it's not in the scope of this class, but that is an option for you. And if you like Excel and if you're really good with Excel, you can probably customize this really easily. Okay, so we're going to focus on these 3: longhand, formula, factor table, and financial calculator. I also said that on top of 4 methods, there's 1 tip. And here's the tip that I want to share with you. Whenever you're in doubt about a finance question dealing with time value of money, draw a timeline. Okay, draw a timeline. I want you to, let's say that we were going to have an example that you put $10,000 aside today. So let's say that, you're going to put $10,000 aside today. You're going to invest it. It's going to grow at 6%, and you're going to leave it invested for 18 years. You want to ask yourself, how much will this be worth? First thing, notice that the 10,000 today, that's the present value. The 6%, that's the I. The 18 years, that's the N. The missing variable, the one that we're searching for, is future value. So you might get overwhelmed. Just slow it down. You draw it like this. Draw yourself a timeline. Today is always 0. Okay, today is always 0. And you're going to have 1 year, 2 years, 3 years, all the way to 17 and 18 years. And what we're saying is you're going to set aside $10,000 today. That money is going to move through time. Specifically, that money is going to move forward for 18 years at an interest rate of 6%. And what you're trying to figure out is the FV. So whenever you're in doubt, draw a quick little timeline, especially if you have a really clunky word problem. Say, there's so many words. How do I do this? Slow it down, put a visual organizer together, identify your givens, solve for the missing one, and you'll be set. Okay, so those are your 4 methods to solve. All right, with that said, now let's get into it and let's do some actual work and let's learn about our different calculations. We're going to start off with lump sums, and we're going to deal with 2 types: the future value of a lump sum and the present value of a lump sum. So let's get into that and let's start talking about number 1, the future value of a lump sum. Here's what this is saying. So here's the context. If you have a lump sum of money today, how much will a lump sum of money that you have today, assuming that it's going to grow at a particular interest rate over a certain number of periods, how much will it be worth at the end of those periods? Okay, Now, notice that this is not an annuity. So we don't have a PMT. It's a lump sum, but we can still put some labels on it. The amount that you have today, let's do this at some color contrast, that's your present value. The interest rate that it grows at, that's going to be your I. The number of periods that it's going to grow for, that's your end. And you're trying to solve for what's it going to be worth in the future, and that is your FV, which is what you're solving for. Okay. So it's a pretty straightforward thing. One of the most common applications of this calculation is, if I invest some money today, what will it be worth later? So that's a very common way to do it. For all of these, we're going to learn the context, and then we're going to do some examples. On the website, in addition to the tables that are here, you're also going to see this handout. It's on the website for you, so you can actually follow along on this as I'm doing the calculations. Okay, so here's an example. You just had a child. You're going to place $10,000 into an account. It's going to earn 5% annually. And you want to know how much the account will hold 18 years from now when your child goes to college. Okay. The first thing that we're going to do, we read the question. First thing we're going to do is we're going to organize ourselves. We're going to slow it down, take a deep breath, and organize. So we'll start off with a timeline. So it's going to look like this. Today is day 0, year 1, year 2, year 3, year 17, year 18. You put $10,000 in today, and that money is going to move forward in time. It's going to move forward for 18 years at a speed or an interest rate of 5% or 0.05. Got it. The other thing I like to do on top of the timeline is, especially for really clunky problems, I like to give myself a little organizer. So let's get our variables here. PV, FV, N, I, and PMT. Present value is 10,000. The future value, that's what we're solving for. The N is 18. The I is 0.05. And the PMT, because this is a lump sum, it's going to be 0. So just by reading the question and doing an organizer, we can now move forward and very simply solve it. So let's solve it. Let's solve it first with the formula method. Okay, so here's the formula. The future value of any sum is the present value multiplied by 1 plus the interest rate raised to the exponent of n. You sometimes hear people say, oh, money grows exponentially. In fact, that's one of the few times that people are using the word exponentially correct. If you look at the formula, the future value is equal to the present value multiplied by 1 plus the interest rate raised to the exponent of n. That's the power of time, because we're always going to we're going to have exponential growth around the time frame. So it's really powerful force. Let's put some numbers in. It's 10,000 times, that would be 1.05 to the 18. That's going to be 10,000. If you were to do on your phone 1.05 to the 18, you're going to see that that's 2.4066. And miraculously, that $10,000 that you put in there and just walk away from over the course of 18 years will grow to be $24,066. Okay, so that's using the formula to solve this. Let's see if we can get the same numbers the other way on the TBM table. So Remember, we're looking here at an N of 5% and in N of 18 years and an I of 5%. Let's go to our tables and let me clean this up a little bit. Now we're searching here for the future value, so you know that we're going to use table A1. It's the future value of a lump sum. Now we have N is 18 and I is 5. We put 5% and drop this down, and then go to N is 18 and go across, we see right here this magical thing, the intersection point, the intersection of N equals 18 and I equals 5% is 2.4066. Here's our formula here. When it comes to the TVN tables, the future value of any lump sum is equal to the present value times what we're going to call the future value index factor for a particular N and percent. Okay, this idea of future value interest factor, which we're going to call FVIF, is always going to be a function of the N and the I. If you were to go here, the future value interest factor for 18.5% is 2.4066. The future value interest factor for 18.5% equals 2.4066. And therefore, the future value is the present value of $10,000 times the FVIF 18.5% equals 10,000 times 2.4066. And it looks like we got it, 24,066. By the way, in case you didn't notice, this table right here, that 2.4066, that's basically the value that we got here when we did that exponent. So the factor tables basically give you a nice little shortcut so you can avoid doing all the hard exponent work and just finger here, finger there, touch it, and that's your number. Beautiful. Okay. So that's our second way. Our third way is the financial calculator. Now, how do we do this? Well, on this one, it's going to be a bit clunky because I'm going to have to click over, but let's first get our numbers right. So let's go to our thing. We said that we had present value 10,000, future value we're looking for, N is 18 and I is 5%. So I'm going to click over to here. We're going to clear this. We're solving for future value. Let's fill in our fields. That's going to be messy. I don't know if I can get this. Okay. The N is going to be 18. The interest rate we said was going to be 5% per year. We're putting in $10,000. Now I'm going to enter that as negative 10,000. The shorthand with the financial calculator, money that you contribute in is a negative, money you pull out is a positive. That's just the way the numbers work. And the payment's going to be 0. Hit calculate. And there you go. The future value, $24,066.19, confirming what we said. So we have found that there's 3 ways. Financial calculator gave us 24,066 as well. There's going to be 3 ways that we can solve these problems. And since the numbers are the numbers, they're going to be the same answers all the way through. Maybe a small little rounding here, but that's okay. Let's now go to our second calculation. The present value of a lump sum. Now, this kind of question is asking, you don't have a lump sum of money right now, but you're going to receive money at some point in the future. So if there is a lump sum of money that you're going to receive at some time in the future, What is that money worth today? What is it worth today if it grows at a particular interest rate over a certain number of periods? If we put our jargon on top of this, the amount that you're looking to receive in the future, that's your FV. The interest rate you're going to get, that's your I. The number of periods is your N. The question of what it's worth today, this is the PV. And that's why it's the question mark. We're searching for it. What are some of the applications here? Well, one of the most common applications is if you're an investor, you want to take on a project, you need to know what it's worth today. You know, I offer you something. I say, hey, I'm going to sell you a rental property. This rental property will generate some money in the future. You have to decide what its fair market value is today, given its ability to grow in the future. So the current value of an investment's earnings can be done with this. And an even simpler one is this. Suppose that you're saving for a future goal. I want to take a vacation in 5 years. I want to have $12,000 ready. So in 5 years, I need $12,000. How much money do I have to set aside in the bank today? What's the present value that will grow to that future value? Okay, so this is a really good one for planning. Let's do an example. You just had a child. Now in this one, we're going to change our scenario. You just had a child. When the child turns 18, you want her to have $10,000. So you want to be able to give a $10,000 gift to this kid when they turn 18. You can earn 6% annually. The question then, how much money do you have to set aside today to reach that goal? So let's think about it. Well, she was just born, so 18 years is our N. You want her to have 10,000, that's the future value. It's going to grow at 6%, that's the I. The question is, how much money do you have to set aside today to make it work? Okay, we can do this again with a timeline and an organizer. Here's our timeline. 0, 1, 2, all the way to 17 and 18. But in this case, the $10,000, the FV is way out here. We're going to try to discount this and pull it back to the future, back this way. We know it's going to grow at 6% for 18 years. So what we're really looking for, what's the amount of money here that will generate 10,000 there? We can also do this as an organizer. I like these. So we'll do PV, FV, NI, and PMT. The present value now is what we're solving for. We don't know that variable. The future value is $10,000. The N is 18. The I is 6% or 0.06. It's a lump sum, not an annuity, so we're going to put a 0. Okay. So how do we solve this? Well, 3 ways. Let's go formula first. On the formula, it's the present value is equal, since this is really the flip side of the future value, we're just inverting the formula. So the present value is equal to the future value divided by 1 plus the interest rate to the exponent. Okay. So in this case, the present value would be equal to the future value. That's $10,000 divided by 1 plus 0.06 to the 18 equals 10,000 divided by 1.06 to the 18 equals 10,000 divided by 2.8543 or $3,503.44. In other words, my friends, if you were able to set aside today $3,503.44 in an account that earns you 6%, in 18 years, that will have grown to $10,000. Okay. So notice that we're putting a price on something today, given its expected value in the future. We can also do the TVM tables, which might be easier. So here's our TVM table formula. In this case, it's going to be the present value is equal to the future value multiplied by the present value interest factor for n and a particular I. Okay, so now we're looking at the present value interest factor. In this case, we would need the present value interest factor for 6% 18. Let's go to our TVM tables. Now, in this case, it's present value, so we've got to be looking at our table A2. The future value, let me get this a bit bigger. The future value interest factor, oops, that's the wrong one. My apologies. We don't need A2, we need A3. Yep, that's it. We're doing it for the lump. We're doing it for the lump. So we're going to do it at A3, which is the present value interest factor for $1. We know we're looking at 18 years. So let's do our first line here at 18. And we know we're doing 6%. So let's also find 6% and drop that down. And look at that little magic number right there where they intersect. 0.3503. 0.3503. That is the present value interest factor, 6% 18, 0.3503. We plug that in, and our present value will be 10,000 times 0.3503, or $3,503. So this is telling us, first of all, we see the alignment, 3503, 3503. You put $3,503 in today, let it sit like in a crock pot for 18 years at 6%, it's going to grow to $10,000. And we could also do the financial calculator. Let's see. We'll go back to our numbers here. So now let's go to our calculator. Hopefully there we go. We got to clear it. Now, in this case, we're searching for the present value. So we're going to click present value. All the other ones we can fill in. So our number of periods is going to be, I need my keyboard here. If I can't find it, we'll just get out and move on. There we go. It's going to be 18. We know that our interest rate is 6. This is not an annuity, so we're going to have a 0. And we know that we want to have $10,000. I'm going to leave that as a positive number because we want to be able to pull that out. We hit calculate. And there we go. $3,503. Notice there's a negative sign on that because that implies that we have to put out 3503 today. That's the negative sign to bring it back in. So there we go. 3 different ways to do it, and we did it. Okay. So with that said, we're done with our lump sums. The last part of this will be annuities. Now, annuities, remember, refer to recurring payments, a recurring series of payments. I want to be clear that the word payment does not just mean money you're spending. It could be money that you're contributing into an account. It could be money that you're pulling out of an account. Okay, the direction of the flow of money, whether you're putting it in or pulling it out, makes no difference to the math involved here. Okay, there's going to be 2 types: the future value of the annuity and the present value of the annuity. And once again, we know that an annuity is a series of ongoing payments. It can either be money put in to the account or pulled out of the account. The other thing to point out is that technically there are 2 different categories of annuities. We're going to stick with ordinary annuity. That's the most common one. With an ordinary annuity, the payment occurs at the end of the period. Okay, this is the default, so this is what we're going to stick with. Here's what an ordinary annuity might look like. It's like this. You're going to have, today is day 0, year 1, year 2, year 3, etc. That's where the payments occur. In other words, the first payment occurs at the end of the first year. There is, however, another type of annuity, which we will not cover in here, but so you know, called an annuity due. With an annuity due, the payment stream begins at the beginning of the period. So an annuity due would look like this: 0, 1, 2, 3, etc. You're going to have PMT like that. Okay, it's just the timing of the first payment. But since the default is ordinary annuity, that's what we're going to stick with. Okay, so let's now move on to our third type of calculation. We're moving on to the future value of an annuity. What we're looking for here, what we're asking, if you make a series of ongoing consistent payments over time, how much will that series of payments made over a certain number of periods and growing at a particular interest rate, how much will it be worth at the end of those periods? Let's put some words, some ideas on top of these words. How much will a series of payments, so that's your PMT, that's how much you're kicking in every period, made over a certain number of periods, that's your N, growing at a particular interest rate, that's your I, what will it be worth at the at the end of those periods? That's your future value. And that's what you're going to solve for. Now, I put FV right there, but I'm actually going to change that. I want to make it clear. So we're going to actually call this FVA. So we can really stress that's the future value of an annuity, keep us consistent. The other thing is here, you might notice that there's something missing. We don't have any PV. We're going to assume, unless the problem tells us otherwise, that there is no present value. So you're starting with an empty account and contributing in. Okay, so now we can put some variables on top of the jargon. The applications for this is really the key to understanding long-term investing over time, which is something that you're going to do, and I'll teach you how to do that. One of the applications is how much must you contribute to an investment account? So this is your PMT. Given a particular rate of growth, which is your I, over a number of periods, that's your N, in order to achieve a particular size nest egg, that's your future value. Notice that we're solving for PMT. It's an interesting thing. A lot of people would say it's an annuity problem. They should give you the PMT. They can, but look at this one. This question is saying, I'm planning long term. You might say in 20 years, you might say to yourself, in 30 years, I want to have $1 million in my account. How much money, therefore, do I have to contribute every year or every month? Doesn't matter. How much money, what PMT do I have to contribute to get that million in that number of years? Okay, so these are, and I'm going to call this, by the way, FVA. Make it real clear. These are really powerful calculations because with this simple tool, you can start doing what amounts to really life-changing planning. Okay, so here's an example. You just had a child. You plan to place $500 every year into an account earning 6%. How much will the account hold when the child turns 18? Now, since the child was just born, we know that the present value is 0. The amount that you're going to place every year is your PMT. The 6% is your I. The child will turn 18. That's 18 years. We're solving for this. How much will the account hold? What will be in the account? And that, my friends, is the missing variable, the FVA. We can do this in a couple of ways. Let's do the organizer first. PV, FV, NI, and PMT, nothing here. We're solving for that future value. The money's going to flow through time for 18 years. It's going to flow at a speed of 6% or 0.06. And the payment is going to be 500. Since we're making it, let's put a negative sign because we're going to be kicking that payment in. So right here, we already have what we need to do a calculator thing. Nice and easy. But in case you want to be visual, let's do our timeline. It's going to look like this. 0, year 1, year 2, year 3, year 17, year 18. We're going to put $500 in every year. Now, here's the key to an annuity. This $500 that I put in year 1, it's going to grow for 18 years at 6%. So this money is going to carry forward. And that's going to grow for 18 years at 5%. And that's going to have a future value attached to it. The $500 I put in year 2 is also going to grow at 5%. Sorry, pardon me, 6%. It's also going to grow at 6%, but this is going to grow for 17 years. That'll have a present value. In fact, if you really think about it, I equals 6%, N equals 16. Each of these separate annual contributions represents a lump sum. So if you were a glutton for punishment, you could decide to just say, I won't do it as an annuity calculation. You could just do 18 future value calculations and add them up. But that's messy. And you don't have to, because ultimately, the future value of the annuity is the sum of all of those individual flows together. So there's a simple, elegant way to do it. Now, with that said, let's get into our 3 methods. The formula, you're not going to want to do, but here it comes. The future value of an annuity is equal to the payment multiplied by, here it comes, 1 plus the interest rate raised to the exponent of time minus 1 divided by the interest rate. So there's your formula. The future value of an annuity is equal to the payment multiplied by 1 plus I raised to the n minus 1, all divided by I. In this case, it would be equal to 500 multiplied by 1.06 raised to the 18 minus 1 divided by 0.06, which is going to be equal to 500 times 1.8543 divided by 0.06 equals 500 times 30.9057 or 15,452.13. By the way, kind of a miracle, huh? Kind of amazing. $500 every year will grow to way more than you can imagine because of the power of time, because those early $500 contributions are going to have so much time to grow, and you're going to get that compounding effect, and that's how you can get 15,000 out of what doesn't seem to be a whole lot of contribution. There it is. Now, that's a hard formula. So we have another way, an easier way. Let's go to our tables. Here it comes. The future value of an annuity is equal to the payment multiplied by the future value interest factor for the annuity for a given N and I. Now, in this case, we need to find the FVIFA, the future value interest factor for an annuity for 18 years and 6%. Let's go to the tables. This one, I believe, is, here we go. This was A2. Future value interest factor for an annuity. Now, we're looking again at 18 and 6%. So let's take 6% and drop it down. And let's take 18 and take it across. And look what we got right there. That magic intersection point, 30.906. 30.906. Again, what this means is if you put $1 in every period for 18 periods growing at 6%, those $1 contributions would grow to $30.906. That's what it means. But we're not putting in, so that's going to be 30.906. But we're not putting in $1, we're putting in 500. So we multiply the 500 PMT times the 30.906, and we're going to get 15,433. Notice again, we have 30.906 right there. That's basically the shorthand of this beast of an equation up there. So we can always use our tables to really shorten, make it easier, really easy to solve. Okay. And then finally, we can do a calculator as well if we chose. Let's go to the calculator. This will be kind of clunky, so forgive me for this. Sorry. Let's go to the calculator. And we need to clear. Now, in this case, we're solving for the future value. So we're going to go here. The number of periods, get my keyboard up. The number of periods is going to be 18. The interest rate we said is going to be 6. The present value is 0. And now we're going to have payments of 500. Now we're going to put a negative sign because that money is going out. So we're going to put negative 500. And there you go. 15,453, which I hope, if I did this right, will be what we said. Oh, sorry, 15,452.83. So 15,453. Yep, there it is. That's 433. That's weird. 453. I may have done this one wrong. I think that's 453. Sorry about that. But there we go. 15,453. So once again, we have 3 different methods. Because the inputs are the same, the method doesn't matter. The outcome will be the same. Yeah, I just multiplied that wrong. So I should have put 15,453. So forgive me for that. There we go. All right, we're almost there. Let's wrap this thing up. The last one is the most powerful one. The present value of an annuity. So we got the future value, now the present value of the annuity. This is asking, here's the context of this. Suppose that you're entitled to receive a stream of payments in the future. Think about that. You're entitled to receive a stream of payments at some point in the future. How much is that series of payments that you're going to receive in the future? What is it worth today, given a particular interest rate and number of periods? So the series of payments is the PMT. The interest rate is the I. The number of periods is the N. What it's worth today is the present value of the annuity, and that's what we're solving for. There's a lot of applications. This is really the most powerful one. The applications, you know, they're not obvious right away, but once you start thinking about this and practicing, it becomes super powerful. This is probably the most powerful one in your toolkit. Here's the most obvious one. If you think about retirement, the day that you retire, the day that you say, no more work, I retired today, you're going to need to have a lump of money in your nest egg that you can draw on every month in retirement or every year in retirement. how much money do you need to have in that nest egg today, given a certain interest rate, in order to generate a stream of money in your retirement? Interesting. So right here, I mean, a lot of people struggle with retirement planning. They say, I have no idea how much I have to save. Well, this is the first step in the process. This will help you to figure out how much money do you need to have in your nest egg on the day that you retire in order to draw money down in your retirement. Now, notice that in the first one, we needed to know how much money you need in the account today. Take a look at this application. Suppose that you actually have a retirement account that has money in it today, and you want to retire today. So now we're not going to figure out what we did in the first one. In this one, we're saying you have money in your retirement account. It's going to grow at an interest rate, and you want to be retired for a certain number of periods. You're going to estimate the lifespan you have. Now we're solving for the PMT. Think about this. In this case, you have a retirement account, which is going to be the present value of the annuity, but that's a given. You know it's going to grow at a certain interest rate over a certain number of periods. Now we're solving for PMT. We're trying to figure out here, hey, what's the amount of money that I can safely take out so that I don't exhaust my nest egg and go broke when I'm old? Powerful. And then the other thing is, this is the basis of all loan payment calculations. Because if you think about it, a loan is basically a PVA problem. You're given money right now. That's the PVA. You're going to make a series of payments back to the bank or back to the lender to pay it off. That's your PMTs. That's what you're solving for. Okay. So let's do a last one here, and then we'll wrap it up. Example, you want to retire today. You want to receive an income of $100,000 per year for 20 years. You're going to have your money grow at 5% in retirement. Let me take a pause right there. Here's what it means. Whenever you retire and you have a nest egg, every year you're going to draw some money off of that nest egg. But what's left in that nest egg is still going to grow because it's still being invested. So every year you have your nest egg, you draw a bit, the rest of it grows. The next year you draw a bit, the rest of it grows. Okay, so that's what we mean that you're going to have a growth rate of 5%. People say, but you're retired. Well, yeah, but you're not taking out your full nest egg. So the amount that's left in there after you take your annual payout, that's still going to get to grow, in this case at 5%. So you want to retire today. That's D0. That's today, day 0. You want to receive an income of $100,000 per year. That's your PMT for 20 years. That's your N. Your growth rate is 5%. That's your I. Here's the question. How much money do you need to have on hand today to make it work? How much money do you need in your nest egg? That's a PVA question. Let's first do an organizer. That's a little bit easier on this one. PVA, the FV, the N, the I, and the PMT. The PVA, that's what we're solving for. Now, the future value is interesting. We're going to assume in this problem that you expect to basically live, you will die at the same time that your money wipes out and goes to 0. So the future value is assumed to be 0. Now, this can change. Suppose that you say that you want to have $100,000 left in your account on the day that you die to take care of your needs, leave some money to your kids or whatever. And you just set that future value to 100,000. But we're going to assume 0 to keep the problem clean. The N, you're going to be retired for 20 years. The I, you're going to earn 5%, and you want to take out $100,000. We're going to leave that as a positive because we're going to draw that money out. Negatives are what we put in, positive we draw out. Okay. You can also basically do it as a timeline. The timeline would look like this. 0, 1, 2, 18, 19, and 20. And basically what we're saying is you want to draw $100,000 out in year one. You're going to pull that back. That would be N equals 1, I equals 5%. You're going to pull $100,000 at year two. That'll be pulled back. N equals 2, I equals 5%. And you get the idea. All these future streams of money are being pulled out. Once again, like the third example, the PVA of an annuity, it can just basically be done as 18 separate lump sums, but that's a hassle and you might mess up. So instead, we just conceptualize that the PVA that we're searching for is basically the sum of the individual present values for all the streams that we're talking about, okay? Now, that looks really hard, but it's not. So let's just get into it now. Let's solve, and then we'll be done. Now, this formula you don't want to do. It's nasty. The present value of an annuity is equal to the payment multiplied by 1 minus 1 over 1 plus I raised to the N over I. This is not fun. Once again, the PVA is equal to the payment multiplied by 1 minus 1 divided by 1 plus I raised to the exponent, all divided by I. Okay, so that's the formula if you chose to use it, which you can, maybe do experiment, but it's a hassle. Instead, we know we have shortcuts in finance now. Let's go to our TVM table. And here's our formula. The present value of the annuity is equal to the payment multiplied by the present value interest factor of the present value interest factor of the annuity for a given N and I. Now, in this case, the present value interest factor of the annuity, our N was 20 years, and our I was 5%. So we go to our tables, 20 and 5. This is going to be table A4. The present value interest factor for an annuity. We said we were going to do 20 years, so we go to 20. And 5%, so we go to 5. And look right there, that magic intersection point, that unique number that corresponds to an N of 20 and an I of 5 is 12.462. Let's take that back here. 12.462. So in this case, our payment is going to be 100,000 times 12.462. And what this tells you, my friends, is on the day that you retire, you need $1,246,000. Sorry, let me take that back. $1,246,200 in your nest egg. Another way of saying this is, if today you had $1,246,200 in an account, you could draw $100,000 a year out, and it would last. You could do that for 20 years. Assume that your money grows at 5%. Okay, so that's pretty impressive. Now, that's important. But I said to you a moment ago that this was the real important formula, because check this out. Take this right here, and let's take this formula and let's tweak it. Since the PVA equals the payment times the present value interest factor annuity, we can swap these around and we find that the PMT is equal to the PVA divided by the PVIFA. So we can use this to solve for the size of nest egg that we need. we can use this to solve for the size of the payment. It's a really great way. You can just tweak the formula and you can do a whole lot of problem solving. The third way, again, financial calculator. PV is what we're solving for. FV is 0. N is 20. I is 5% or 0.05. And PMT is 100,000. We're hoping it comes out to 1.246 million. Let's see if we can get this calculator to work for us. Let's clear it. We're solving for PV. And we got to get our keyboard up. Number of periods was going to be 20. The interest rate was going to be 5. The PMT, we're looking to draw 100,000 a year out. The future value, we're just going to say that we're not going to have any future value. We want to basically exhaust the account. We want to expend all the funds. And if we calculate, there it is, 1,246,221. Notice the other thing with this, suppose that you were to say, you know, I expect I'm going to be alive for another 20 years. But instead of leaving 0, I want to leave $50,000. By just tweaking one little variable, you can totally change the numbers. We call this in business school scenario analysis or situation analysis or sensitivity analysis. You can go through a lot of different thought experiments, tweak one variable at a time, and this calculator makes it very easy. Check this out. You would need 1.246 million to have 100,000 and leave nothing behind. But actually, we would need, if you simply had 1,265,000, just a little bit more, I think that was correct, just a little bit more. Yeah, just a little bit more money and you can leave $50,000. So there we go. And that's our calculator. So we've done a lot today. Let's summarize and conclude. Again, we have time value of either lump sum or annuity. We have either present value or future value. So at its core, we have 4 different types of problems to solve. Each problem can be solved with either a formula, a calculator, or the factor table. And the better you get at this, the more applications you're going to see. Let's conclude, put all of our knowledge together, and let's get some insights and takeaways. A wise man once wrote, "Those who understand compound interest collect it, and those who don't understand it pay it." Question is, which one will you be? Okay. When it comes to growing wealth and accumulating wealth and really having the means to achieve all those goals that you want to achieve for that great life that you deserve to have, what are some of the insights and takeaways that we can draw? Well, I would say insight number 1, time is your best friend or your worst enemy. This time value, the numbers are the numbers. The math is the math. If you change the N, it's going to have predictable effects. So time can be your best friend or your worst enemy. This means that you have to start early. The sooner that you start saving for retirement, you imagine you get your first job out of college, let's say, you've got a job, or even you get a job when you're younger. You even put a little bit of money away, and that money can grow for 40, 45 years. By starting early, you're going to do great. Okay. It also means don't start late. It's interesting when you run numbers, you find that a lot of people will say, oh, I didn't want to start saving right away. I'll wait till I'm 30, get out of college, let's say I'm 22. I don't want to save at 22. I'll wait till I'm 30. It's only 8 years. That can't really hurt me. It can really hurt you because time is your best friend or your worst enemy. So start early. Also avoid debt. Money that you own and money that you borrow, they behave the same when it comes to TVM. The numbers are the numbers and the math is the math. The numbers work in your favor if it's your money, but the very same forces that will grow money that you own will grow debt that you borrow. So time is powerful. If it works in your favor, it's great. But if you borrow money, the same forces that worked in your favor when you own the money will really hurt you when you borrow it. So avoid debt. Once again, we know that you want to invest over time, and this requires net cash flow positive. You have to live below your means. You have to spend less than you earn to generate NCF positive to make all this stuff from today work. And that leads to what really amounts to a focus question I want to leave you with today. As you contemplate your future, you can choose to go in one of two broad directions. You can choose to be a capitalist or a consumer. A capitalist saves money, acquires assets, lives below her means. A consumer spends what comes in and sometimes even spends beyond what comes in. You can't be both. You can either be a capitalist or a consumer. The question before you, my friend, which one will you choose? If you make the right choice, and you know what my answer is going to be, you be a capitalist. You live below your means. You run net cash flow positive. You pay yourself first. You let time work for you. You can be the millionaire. You can fulfill all those goals that you have. You can start building generational wealth to take care of your descendants down the line. Okay? Thanks for tuning in today. I'll see you next time. Be good.